Forgot to start recording. Okay, so you guys all agree this is clumped, and we said, why would a species arrange themselves like this? Okay, what are you coming up with? What do you think?
So like danger comes and
Safety in numbers. Have you ever gone someplace with a friend so that you wouldn't get picked on? You ever feel more comfortable walking with? I don't want to go by myself. No, you come with me. No, I don't want to go. No, come with me. We got. Come on, let's go. Okay. That's what they're doing. This is pretty common in species that are prey animals, because if you're in this little cluster, if you're out here, do you think it's more likely that you die than if you're in here? Yeah, probably. They pick from the edge of the pack. Never be the last one in line at the haunted house. Stay in the middle of the group. It's where you're safest. Not that you're really going to die in the haunted house. But anyway, clumped distributions, and we'll label this, are usually social. So this is a safety in numbers thing. This is a, hey, let's stick together thing. What else can it be? So here, what we have here are actually mule deer. And out west, they are preyed on by wolves. And if there's a cluster of them, the wolf can't get them all. So your odds go from, if you're out here by yourself being 100%, if the wolf comes at you, it's 100% you're the one who's attacked, to in the middle of a cluster being maybe 1 in 10 odds that you're the one who gets attacked. So clump distributions are great for social reasons. There are also species that are just kind of never alone. They call them gregarious species. There are some bird species who you never see solo. Those are clumped distributions, and they're often social. There's one other reason you might see a clumped distribution. Have I mentioned Laura Ingalls Wilder? Once or twice? 5 times? 64 times? So I'll just recap. She was born in, I want to say, 1869, and her family packed up a covered wagon with her and her siblings in the big woods of Wisconsin, and they headed off to the western prairie. They ended up settling in Kansas. They moved all over the place. They went to Minnesota, ended up in the Dakotas. And she writes in great detail about the prairie. And she writes about a sea of grass. And this is grass so tall that a man on horseback could disappear into the prairie. This is the American tall grass prairie. It's a biome that still exists in a very few places in the middle of the continent. It's a pretty amazing ecosystem. But then she talks about how they would then, rising out of the prairie, they would see trees. Now, I know it looks like aliens, but it's actually not. And it's just the worst trees ever drawn. They would see trees, and that was a huge excitement. Number one, because it broke up the monotony of the landscape. But what did those trees mean? That's what somebody else said. It does mean life, but it means a very specific thing, water. The trees in these prairie environments, because the prairie was too dry to support trees. The only place you would find trees was down along the creek bottoms. And they would be traveling for days and days and days in upland environments. And of course, they're carrying all their own water on board. And so seeing trees in the distance meant you were coming up to a stream, river, creek, and it was a chance for water. And this is actually a picture. Now, of course, this is farmland. That's partly artificial. But this is kind of what we're talking about, where we have, sort of prairie-like land here, and then the only place we see trees in this image are right along the creek, because that's where trees can be supported. What kind of distribution is that? If we look at that from a top view, and we're looking at trees, what kind of distribution is that? It's clustered or clumped. Dispersion. I should say dispersion pattern. We should be careful with the word distribution. That's a clumped dispersion pattern. Those trees are clustered around the water. The water is the resource they need. They are clustered or clumped around water. So it's not social here. It's just a matter of that's where the resources are. Okay. This is the only other one I'm going to really review with you. Random, I think you probably get. What is this? Which dispersion pattern is this? Now, it's not perfect, but it's even. This would be considered an even distribution pattern. And this is an image of a species that actually does this. This is a nesting colony of northern gantrels. They're a seabird, and they form colonies like this. So, do you remember in kindergarten they would tell you, okay, everybody stand up and spread your arms out. Now, swing your arms around until you don't hit anybody. Did you do this? That's what they're doing in essence. They're swinging their wings around until every one of those birds is perched on a nest. And those nests are distributed in such a way that they each have about an even amount of space. So is that a social thing that's causing them to spread out like that? Yeah. But it's not social, hey, come with me. Let's be side by side. It's like, okay, no, you stay away from me. I've got my nest. You've got your nest. You stay over there. It's social, but it's a different kind of social. All right, so if we want to count this population, if we want to get an estimate of the population size, you going to volunteer to go count every single bird?
No.
I'm not either. So what's the method we're going to use? Sampling. We're going to walk through a sampling worksheet. This is where, remember I said, I can either give you the video as homework, or I can give you the worksheet as homework. You had the video, and it was really not even homework because it was Friday in class. The worksheet you're going to work on here. You can work at a table with a group, and I want to ask you to do this. Read the whole directions before you start. That will help you. So looking at your estimates. Now, it's interesting. In the other class, we have 6 groups, and their estimates came out closer when we averaged them, and we had like a 210, 215. We had... Are your estimates a perfect count? No. Are they good enough to have a pretty good sense of the population? Looking at those estimates, would you say it was reasonable if someone came along and said, there are 1,000 sunflowers in that field? No. Because based on multiple estimates, we're saying, yeah, it's under 300. We don't have any number under 300. We don't have any number, or we don't have any number over 300. We don't have any number under 200. So we would say it's somewhere between 200 and 300. That's not a terrible ballpark. We know it's not 10. We know it's not 1,000. It gets us in the range. Now, for actual count, I believe that the actual count is 228. So a couple people are one off. That's okay. If you're counting live specimens out in the field, you're going to have actual count numbers that are off. So let's talk a little bit about greed. Greed, really? Yeah, greed and human hardwiring. Do you know why you have to randomize your plot selection?
What selection?
Your plot selection. When you pick a grid.
I thought you said plot selection.
Plot.
So I got really confused.
No, you would be confused. Why do you have to randomize that? Because you know what humans want? The most. And it's not even conscious. If you look at those plots, those grids, and you go to select, you will unconsciously pick the ones that have the most in them. Years ago, I worked as a watershed coordinator, which meant I did basically stream ecology stuff, and at one point, I had to go, one of the things you do in stream ecology is you have to do rock sample size. So I got roped into, so everybody take your finger and go like this. Imagine a little teeny tiny pebble. And then imagine a bigger pebble. And then imagine something the size of your hand and something the size of your head and something you can't even move. The habitat in the stream is dependent upon the abiotic factor, the size of the rocks. Literally makes a difference in terms of what kind of energy the stream has and what kind of life we'll find there. So I had to do a pebble count with the district engineer. And I was the low person on the totem pole, which meant I was the one who got to go in the creek in December in chest waders. Everybody stand up. Now, in chest waders, so up to somewhere around here, Come on. And you have to get a good wide stance so you don't fall over in the creek because it's December, and if you top your waders, you're going to die. Put your finger up in the air. Close your eyes and then bend over. I kid you not. And you have to get 100. Now, the first thing your finger touches, that's what you pick up and you measure. And then the engineer who's safely, warmly, dryly up on the bank recording all this on his laptop, he was a nice guy, but still, you can go ahead and sit down. He recorded did I mention I had to get 100 pieces of data? Yeah. The good news is after 15 minutes, your hands stop hurting because you can't feel them anymore, so that really helps. Of course, it also makes it hard to pick up the rocks and measure them because you literally have calipers in the stream and you're literally picking them up, measuring the medial axis, and hollering it out to Randy, the engineer. He was such a nice guy, but he wasn't going to go in the stream in December in his chest waders. No. You randomize because if you don't close your eyes and put your finger up and bend over, you know what you will do subconsciously? You'll pick up the biggest rock in your field of view. You will go for larger pieces. That's why we randomize samples. We have to. I have done biology sampling with students where I take a handkerchief, wrap it around a rock, and you stand there and you throw it backwards. So you can't see where you're looking. Then you count what's in the grid, or we've used hula hoops. You have to randomize because subconsciously you will select where you see stuff. We're hardwired for that. Okay. The questions on this worksheet are homework. You have to try to answer them all. Now tomorrow when you come in, we're going to talk a little bit more about them, but I am going to check them for completion when you walk in. So I want you to thought them through. By the time we're done, you'll have the right answers, but I want you to start your thinking process by answering them on your own. You can use your notes and stuff. Okay? That's it, and I'll give you the rest of the time today to work.